Hello, and welcome to your Homework Explained. Remember that this video is not mandatory and it's not on Play Pause It, which means you can skip forward just to find any particular problem that you want help on. So you also just have the answers posted available for you to skim through if you need any additional explanation, or if you just feel like you could benefit from just soaking in additional explanation. This is the video for you. All right, let's jump in. Given that y varies inversely, so that means that y equals k over x. Varies inversely is x and y equals 10. So I'm going to plug in 10 for y. When x equals 5. We want to solve for our k just so we can use that information to solve for our later pieces. I'm going to get k by itself, which means I need to multiply both sides by 5. So I get that 50 equals k. I still want to make a final equation. And I plug in. Sorry. And so I plug in 50 for k and I get that final equation. And it will help me for the rest of this problem. I'm going to solve for y when x is 20. So I just go ahead and plug that in. I get that it's 5 over 2. In other words, y is 2.5. Next one, we want to solve for x when y is 0.5. Sometimes if there's an x in the denominator or an unknown in the denominator, I get a little confused about what I'm supposed to do. A lot of students try and multiply these two numbers together. That's a big no-no. If you are unsure what to do in this situation, I highly recommend putting this guy over 1 so you can cross multiply and realize that really what you're doing is multiplying both sides by x in order to move it out of the fraction so that now you can divide both sides by 0.5 and get that x equals 100. Basta. Given that y varies inversely, y equals y equals k over x as the square of x. So I'm going to go ahead and make sure, because it says the square of x, so it means that guy's going to be squared. Y equals 10 when x equals 5. 5 squared is 25, so I just made that 5 in here, and then I squared it. Okay, in order to solve for k, I'm going to multiply both sides by 25. So I get that 250 equals k. My final equation is this. 250 over x squared. Using that to solve the rest of the problems, we want to solve for y when x is 20. So squaring that, I plug it into my calculator, and I get 5/8. So y equals 0.625. We want to solve for x when y is 2.5. I'm going to put this guy over 1, cross multiply. $250 divided by 2.5, I'm trying to get that x by itself, is 100. Taking the square root, I get that x is equal to plus or minus 10. Next page. The radius of a satellite's orbit around Earth varies inversely. So it splits up this sentence such that I've got this first part and this second part. The first part is my y, and the second part is my x. Varies inversely with the square of the velocity. I'm going to circle square so I don't forget it, because I really honestly tend to forget that a lot. I'm going to go ahead and to the side figure out what is my constant variation. Actually, not to the side, because that's what literally this whole problem is about. So I get y equals k over x squared, except for y is the radius, which I'm going to let stand for R. I'm going to let R stand for that. And I get that X is the velocity. And I'll let V stand for that. Because then it gives me that given a satellite that travels at a velocity of 7,700, it has an orbital radius of 6.75 times 10 to the 6th power. Plugging those in to the appropriate places. In order to get K by itself, I multiply this guy by 7,700 and I multiply this guy by 7,700. And I get that K is equal to 5.198 times 10 to the 10th power. Oh, and I did it again. That's why. Okay, that needs to be squared, so that is incorrect. I'm going to multiply it by 7,700 again. And the true correct answer is, that looks more familiar, 4.002 times 10 to the 14th power. So since it asks only for my constant of variation, right, that's just K, I've solved my problem. I know I'm probably going to be using this problem for future questions. So I'm going to go ahead and write out my formula for future questions. We want to find the velocity when we have a radius of 7 times 10 to the 6th power. Plugging into appropriate places, R, 7.0 times 10 to the 6th power equals 4.002 times 10 to the 14th power all over V squared. I get 7.0 times 10 to the 6th power times V squared equals 4.002 times 10 to the 14th. In order to solve or get V by itself, I need to divide both sides by this guy. So I get V squared equals, and I take this exact value that was in my calculator before, and I divide it by 7. I'm going to put that into parentheses because I'm paranoid. 7.0 times 10 to the 6th power. And I get 5.72 times 10 to the 7th power. I've rounded here, but I know I'm going to actually be using my exact value here in the calculator. In order to get V by itself, I get the square root of that, and I get that the velocity is 7,561.25. It does not say to round to 3 significant figures, so you could leave it like this. If you decided to round it to 3 significant figures, you would totally be within your right, and that would be 7,560. And the velocity is measured as meters per second. Either would be correct. Sorry, I got a tickle in my throat. Last part of this problem. We're going to find the radius when we have a velocity of 8,000. So I plug in 8,000. Down here. Needs to be squared. So I just make sure to grab my exact value that's in my calculator. Sorry, that glare is so terrible. I don't know how to fix it. But I'm going back up and finding that exact value in my calculator. I'm bringing it down and then I'm hitting divide and then doing 8,000 squared. And I get 6.25 times 10 to the 6th power. X is inversely proportional to the square root of y, and y is inversely proportional to the cube of z. So these are two separate equations. This and kind of splits that sentence up into two different things that are going on. So we've got inversely proportional here, and it splits that section into two pieces. This tends to be our y place, and then this tends to be a square root. And this tends to be our x place. So where I would normally write y equals k over x, now x is going in for the y place. So it becomes x equals k over, and it's the square root of y. And that's how I create that equation. Dealing with the next one, y is inversely proportional. So this is in our y spot to the cube of z, and that's in our x spot. So y is inversely proportional to the cube of z. That one was a little bit more straightforward to make. Now it says find the relationship between x and z. So we want to put x and z in the same equation together. We don't know how they work together unless they're in the same equation. And notice they're separated into two separate equations. So if I want to take two equations and put them together in one equation, it's my system of equations process, right? I want to be able to plug one in for the next. And thank goodness we have this bridge between the two equations. We have this y piece here and this y piece here. And since it's already isolated, I know I'm going to be able to plug this piece in for y like it's a puzzle piece, right? So moving forward, knowing that I need to put x and z in the same equation in order to find a relationship between them, I'm going to do x equals k over the square root of k over z cubed. Now, you might look